This lecture is on beach equilibrium and also helps you with your beach equilibrium assignment. So I'll go over a few key concepts about beach equilibrium, what are the things you have to look out for, and also go over the assignment. So again, this is Crane Beach in Massachusetts here. Um, Again, this is some of the notes are available on your beach equilibrium page here in the beach management. And if you click here, you'll see some of the key important things that we need for the beach to be in equilibrium. So we'll go over some of these things. Have dunes, no steep slopes, ability to migrate inland, and no interruption in long-term transport. So what does this mean? So here, as you can see, here's the Crane Beach. Um, Again, you can see sort of the dry part of the beach right here, and then this is where the waves are coming in. This is the wet part of the beach. So you can see uh, that the beach is fairly wide here. You can use your rulers to sort of measure the dry beach width as well for your particular beach. Um, and you can see it's about 370 feet here. Another thing we can look at is sand dunes. So here you can see deposition of sand. There's different patches of vegetation around it. So this is a healthy sign for any beach. So you can see that the river, the ocean has been sort of washing inshore, inland, um, depositing sand inside. So as you can see, there's lots of sand dunes present here. So as we go here, you can also see that um, here you can see the elevation here. It's about 0 feet down here, and as you go inland here, the dune, the beach is relatively flat. You'll see some elevation, and that's mostly because of this smaller dunes. So there's no really presence of any steep slope. If there's any steep slope or a bluff, then that doesn't allow the beach to migrate inland. So here it's relatively flat, lots of dunes available. So it's a good character to have for a beach to be in equilibrium. So second condition was that the beach should be able to migrate inland. So as I pointed out, if it's relatively flat, if there's no steep slopes, the beach can easily wash inland and be able to migrate inland here. If there's any development present here, if there's any buildings, construction, residential areas that basically impedes the ability of this beach to migrate inland. Um, so just to give an example of a bluff or a steep slope. So here we go in Block Island here. If you go to Block Island, the eastern shore, as you can see here, um, even in Google Earth here, I have the elevation set here slightly exaggerated, but you can see that right along this coastal area here, there's a pretty steep slope here, or a bluff. The elevation down here is about 0 feet, 4 feet. At the top of the bluff, it's about 86 feet. Now that's a fairly steep slope, and what this does is doesn't allow for the beach to migrate inland. So in this case, the beach would be in equilibrium. um, Again, we can go to Block Island here, another healthy sign of dunes right along this coast here. So again, this beach is in fairly equilibrium. You can also see that this is the ocean here. One way that the longshore transport, or the way, or the direction of the travel of the waves is impeded is because of deep water, or is there any barriers here. So here we don't really see any evidence of any deep water right off the coast, and we also don't see any barriers that we mentioned in our earlier lecture, seawalls, jetties, groins. We don't see any of that man-made structures here. So this beach is in a fairly equilibrium context. So let's go to Newburyport Beach in Eastern Mass. So again, this is, here you can clearly see the wet beach here. You can also see the dry beach here. You can see the action of the waves sort of depositing sand here as a result of longshore transport. So again, if we go through our list, it's a fairly good dunes here. Not many really steep slopes here. These are just dunes, height of the dunes. So it satisfies our conditions. There's no steep slopes here. Uh, and again, you can see the beach is fairly wide here. You can measure the dry beach width here. So again, for your exercise, you'll be doing this, measuring the width of the dry beach here. It's about 180 feet. So now you can see how if the beach width has changed over time. I'll take you to another beach now, Crane Beach in Massachusetts. So again, this is the earlier beach, and again, this is in equilibrium. Now let's go to Bank Street Beach. Now we see here that a couple of things. First of all, there's some dunes here, but there's a lot of development right along the coast. You see a lot of barriers here as well. This is a jetty here for the harbor here. We see tons of groins here jutting out. And again, you can see how this has changed the longshore transport here. You can see the sand deposition patterns here. This side is being deposited, the other side is being eroded here. So again, when you see this type of pattern, the beach is not in equilibrium. The longshore transport is interrupted. At the same time, we got a lot of development along this coast here that allows or that impedes the ability of the beach to travel inland, right? So when you have a lot of these houses here, it doesn't allow the beach to migrate inland. So again, this beach is not in equilibrium. Now let's go to take a look at another beach. This is Long Beach Rock. Again, this is the beach right here. So again, you got roads here, you got parking lots here, but the major issue here is, as you can see here, there's a seawall that's built right along here, and this is not good because this is a physical barrier that impedes the ability of this beach to migrate inland. So the waves are crashing here, and it creates further erosion. One thing for your assignment that you can do is also measure the dry beach width, and also with this clock sign here, if you turn it on, you can see historical images. So now you can go back in time. So for your assignment, you can go back in time and maybe take 4 images, 4 clear images here, and you can see how the beach width has changed. So here, this is high tide probably. As you can see, the water is right on the along the coastal area. So you can take snapshot of these various time periods, measure the width of the beach for that time, and see if that has changed. This is Horseneck Beach in Rhode Island. It's certainly one of my favorite beaches if you haven't been here. Again, in this beach here, come to present time here, so again, you see that there's a fairly wide dry beach here. So you can see lots of dunes, sand dunes. The beach can travel inland or migrate inland via overwash. There's no development along the coast, and also there's no interruption with physical barriers. So if you took this beach on your assignment, you can go over time. Maybe take 4 clear images. Let me change the preferences here. So maybe you can take a couple of images over time. So this is for 1995, and you can measure the dry beach width for 1995, let's say. And let's say you can keep, so the dry beach width for 1995 is about 182 feet. Now you can keep the orientation same so that the images don't change from year to year. So now you can go, let's say, another year, 2005. Again, measure your dry beach width for 2005. So again, you can see how the beach width might have changed over time. And just note these beach widths here, right? So we can come back to now 2012, 2013, let's say. Again, you can measure the dry beach width. Looks like it's slightly narrow here compared to this. And then let's say you can come to present here, again measure the dry beach width. So then you'll go through the various conditions that you talked about beach equilibrium and decide on whether the beach is in equilibrium or not. So what happens if the beach is not in equilibrium? This is in Mantoloking, New Jersey. Now if you go back here, right, so this is still in Mantoloking, New Jersey. This is 1995. This is 2007, 2008, 2010. All right, so you can see there's a huge difference here between 2010 and 2012 here. So what happened? This is Hurricane Sandy. So as you can see, the beach was not in equilibrium. The development was right up close to the beach, and as a result, the beach wasn't able to migrate inland. So when there's a big storm like Sandy hit, you see the sand is all, the water just tries to find its way inland, and it's bringing sand inside, and you can see it creating a lot of damages to the houses here. And create a lot of property damage. So this is a typical beach that is not in equilibrium, and you can see the consequences. Similarly, if we go to the Bolivar Peninsula here in Texas, so again we go to close up here. There are a few houses down here right along the coast. Now let's see if we go back to the time, go back in time, and click through the images. You can see how the beach width has changed. Let's say if you take this beach. All right, 2007-8, you can see massive damage in the Bolivar Peninsula here. Again, a beach that is not in equilibrium. During a storm or a hurricane, the water basically migrates inland, brings all the sand, and as you can see, huge property damage, residential areas damage. Again, it recovers fairly well, even right off a couple of months later. And you can still see the damages are still there from that hurricane here, and there are still people slowly moving in. So again, this is a problem with a lot of these coastal areas. You know how there's one big hurricane that hits and damages, causes a lot of economical damages as well as deaths, but then people still come inland and rebuild, and there's no retreat. So again, this comes, it's a big debate in coastal management, in places like Bolivar Peninsula, New Jersey. And finally, we'll take one more look at Rockaway Beach in New York. So now if you were to look at this and you can probably say that this beach is not in equilibrium. There's extensive development right on the coast. You can see these groins jutting out, basically impeding the longshore transport here. And you can see the effects of hurricane damage here in this region. So again, there's been some beach renourishment done. The beach has been widened. Some of these coastal areas are, huge economic activity, or particularly in the summertime. So the beaches have to be renourished, just because every summer there's hundreds and thousands of tourists that come here. So again, I think that gives you an overview on beach equilibrium, how you can use Google Earth to look at the historical imagery. And again, this should help you in your assignment as well. Thank you very much.